Today, in this lecture, we're going to talk about applications of the indefinite integral. We're going to look at a specific example and discuss how to use the indefinite integral to solve this problem. What we want to do is determine the equation of the curve that passes through the point 2, 5 if the slope of the curve is given by the equation dy dx equals 2x at any point. So we're going to have to do some writing. Let's switch over to our notebook. Here we have the same problem. We want to determine the equation of a curve, but we're not given the equation, we're given the derivative of the equation, and we're given a point it passes through. This is important. We're doing the opposite of what we did in the previous chapter, where we were given a function and asked to find the function that gives you the derivative of the original at every point. We're now given the derivative. This is sometimes referred to as a differential equation because instead of being given the function in question, you're given its derivative or some of its derivatives. So let's take a look at how we're going to solve this. We didn't really want to move it that far. Okay. Well, we've got the equation for the derivative, and if this is the slope, and certainly we've indicated it with our notation that it's, if we want y, we're going to invoke the fundamental theorem of calculus, right? We haven't looked at that yet, but this is what we're doing, and we're going to ask ourselves, well, what are all possible antiderivatives of this function? This one here. What do they look like? What are all possible antiderivatives of the expression 2x dx? Okay, and we know what to do. We'll use the power rule for integrals. We'll increase the power by 2 and divide by 2 plus c. And this family of functions represents all possible antiderivatives of the expression 2x. We can simplify this expression a little bit. But we're not done. Remember, there are infinitely many of these. We don't know which of these to choose. And so what we're going to do is we're going to use the fact that we were told it passes through the point 2, 5. That means we know somehow that when x equals 2, y equals 5. Well, 2 squared is 4. And I think we can solve this for our integration constant c. If we subtract 4 from both sides, with c equals 1. So we use both pieces of information, that it passes through the point 2, 5, and that we are given an expression for the derivative of the function. This is how we select a particular antiderivative from the family. And so our solution is y equals x squared plus c. What I want you to do is try to solve a similar problem. You'll need a piece of paper and pencil because you'll need to do some calculations, much like the ones we've done here in this problem. Let's go ahead and take a look at the quiz question. Find the equation of the curve that passes through the point 2, 6 if the slope of the curve is given by the equation dy dx equals 3x squared at any point x. I'll give you a little while to write this down. And let's look at the answers that we can choose from. Is the solution y equal x cubed plus 6, y equal x cubed minus 2, y equal x cubed plus 2, y equal 3x squared minus 6, or none of these? Thank you.